Finally, let's talk about our reactions. When brominating propane, there's propane, two possible mono-bromo products. Well, we studied, of course, chlorination, bromination, same idea. Bromines can go on either on one of these red hydrogens, replacing them, and all 6 of those red hydrogens are identical. And if it did one of those, then it would make one bromopropane. Now, haven't really emphasized the naming yet of these alkyl halides or halogeno-alkanes, but it's dead easy. You got a bromine there, so it's bromopropane. It's on the first carbon, so it's one bromo. Now, if I put it there, it would still be one bromo. There, one bromo. There, one bromo. There, one bromo. There, one bromo. Put it in one of the purple ones. Well, now that will be different. That will be 2 bromopropane. So 2 possible monobrominated products. Now, the generally accepted mechanism involves 2 propagation steps. And if you remember back to our original movie, there we are, the start with chlorine, because that's what I was doing. Chlorine breaking apart to 2 chlorine atoms, these free radicals. 1 chlorine free radical attacks methane was our exemplar one. Of course, here we'd be doing propane instead of methane, making a methyl radical plus the HCl, and then that methyl radical gets another chlorine. Again, in this case, we'll be looking at bromines and we'll be looking at propane instead. Well, there's a bromine radical and there is a propane. And as we said, that propane has got 2 different types of hydrogens, the red hydrogens or the purple hydrogens. Well, this bromine radical can come in and grab itself one of the red ones. If it does that, stick it on the end there, grabbing that red one, making this HBr. And then this primary propyl radical, primary because the carbon on which the radical resides is attached to only one other carbon atom. This primary propyl radical will go find itself another bromine, just analogous to that step. Grab the bromine atom, leaving behind bromine radical. So that's one possibility. Second possibility, as we've already discussed, is that the bromine doesn't grab on one of the red hydrogens, it grabs one of the pink hydrogens, and if it does that, it makes a secondary radical. Secondary because the carbon on which the radical resides is attached to 2 carbon atoms. So again, that can go find itself another bromine atom, bromine molecule, grab itself a bromine atom, leaving the bromine free radical. So very straightforward, I hope you would agree, just applying the mechanism that we've already seen to a slightly more complex situation, because there is a choice of hydrogens to be abstracted by the bromine radical. So a fun one, 2,3-dimethylbutane. Well, there's 2,3-dimethylbutane. You can see the green in the butane bit and then the 2 dimethyls in red. Now what I want you to do is, I don't want you to think of it like this molecule, but let's carve it down the middle there. Let's break that carbon-carbon bond. And if we broke that carbon-carbon bond, we would have this. Okay. And what does that strongly look like? Looks like that. So the way we get 2-dimethylbutane is for 2 of the secondary radicals to come together in a termination step to make 2,3-dimethylbutane. The 2 radicals form a carbon-carbon bond. What would be the second and the third carbons of the butane chain. Hopefully that makes sense. Hope you enjoyed that. See you in future worksheets.